Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Park. Thanks for meeting with me during office hours to talk about forest fire management strategies for my thesis.
Good afternoon, Marcus. I am glad you set this up. Tell me where you are in developing your research question about controlled burns and prevention techniques.
I am trying to compare different prevention techniques alongside prescribed burning. I want to know which combinations reduce the risk of large crown fires most effectively.
That is a focused and practical question. In many ecosystems, the answer is not a single technique, but a suite of strategies. Mechanical thinning, fuel breaks, and prescribed burns often work together.
When you say mechanical thinning and prescribed burns together, do you mean thinning first and then burning?
Yes. For example, in the Sierra Nevada, mechanical thinning followed by low-intensity prescribed burns significantly reduced crown fire risk compared with either treatment alone.
Could you explain why the sequence matters from a fuels perspective?
Thinning removes ladder fuels that allow fire to climb into the canopy. After thinning, low-intensity burns consume fine surface fuels that would otherwise carry high-intensity flames, so the combined effect lowers fire intensity and spread potential.
That makes sense. I read about mosaic burning in Australia, where fires are applied patchily to maintain biodiversity. Is that compatible with prevention goals here?
It is. Mosaic prescribed burns reduce continuous fuel beds while preserving habitat heterogeneity. The goal is to create a patchy landscape with burned and unburned areas, so fires cannot travel uninterrupted over large distances.
So mosaic burns are both ecological and strategic for preventing large fires.
Exactly. They support species that depend on early successional habitats while reducing the likelihood of runaway wildfires.
What about smoke management? I know communities often oppose burns because of air quality concerns.
Smoke management is a critical constraint. We plan burns according to meteorological windows and use techniques like split ignition and holding lines to limit smoke emissions and disperse smoke away from populated areas.
Can you give an example of a specific prevention technique aimed at communities in the wildland-urban interface?
Creating defensible space around homes is one. That includes vegetation removal, hardening structures, and establishing fuel breaks between forest and residential areas. Community education and fuel management programs are also key.
How do agencies decide where to do prescribed burns first when resources are limited?
They use risk assessment models that incorporate fuel loads, slope, historical fire regimes, proximity to communities, and climate projections. Prioritization often targets areas with high ignition probability and high potential for severe fire.
You mentioned historical fire regimes. How important is restoring those regimes as a strategy?
Very important. Many forests evolved with frequent low-intensity fires. Restoring that pattern with prescribed fire helps maintain species composition and reduces fuel accumulation that leads to catastrophic fires.
Are there any specific case studies that show long-term benefits of these strategies?
Yes. Longleaf pine restoration in the southeastern United States combines frequent prescribed burns with mechanical removal of hardwood encroachment. Over decades, this approach reduced severe fire incidents and supported biodiversity.
How does climate change affect the choice of management strategies?
Climate change increases fire season length and drought frequency. Managers must adapt by expanding control burn windows where safe, reinforcing fuel breaks, and integrating landscape-scale planning so treatments are resilient to shifting conditions.
I am planning to use remote sensing in my thesis. What monitoring methods are most useful to evaluate treatment effectiveness?
Satellite imagery and LiDAR are powerful tools. LiDAR can quantify canopy height and fuel continuity, while satellite time series tracks vegetation recovery and burned area. Field plots remain essential for validating remote estimates.
What about risk to firefighters and legal constraints on burns?
Safety protocols are rigorous. Burn plans include contingencies, holding crews, and escape routes. Legal constraints involve air quality regulations and burn permits. Balancing ecological benefit and human safety is always central.
In your experience, what is the main barrier to expanding prescribed burns as a prevention technique?
Public perception and resource limitations. There is fear of escaped fires and concerns about smoke. Many agencies also lack funding and trained personnel to carry out frequent burns at scale.
Are there ways to involve communities to reduce opposition?
Yes. Community engagement, transparent communication about risks and benefits, demonstration projects, and offering technical assistance for creating defensible space can build trust.
How do we measure success for a combined strategy that uses thinning, burns, and community measures?
Metrics include reductions in fuel loading, decreased probability of crown fire, fewer high-severity burn patches, improved biodiversity indices, and reduced losses to property in the wildland-urban interface.
If I structure my thesis to compare treatments across those metrics, do you think I should include cost analysis too?
Yes. A cost-benefit analysis that includes implementation costs, avoided suppression costs, and long-term ecosystem services will strengthen your argument for particular strategies.
One more question. Are there examples where prescribed burns should not be used?
Prescribed burns are inappropriate, where fuel conditions could cause uncontrollable fire, where smoke would endanger vulnerable populations, or where rare soil pathogens could be spread by fire. Each site requires careful evaluation.
This helps a lot. For my methods, I will include remote sensing, field fuel plots, and interviews with land managers about prioritization and smoke management.
That sounds comprehensive. Make sure to document ignition techniques too, such as strip burning or point ignition, because ignition pattern influences burn intensity and patchiness.
I will. Thank you for the guidance. Should I prepare a draft proposal to review next week?
Yes, please. Bring your proposed sites, metrics, and a preliminary schedule for prescribed burns, if applicable. We can refine prioritization and monitoring protocols.
Great. I appreciate your time and the specific examples. I feel more confident about framing the thesis around combined prevention techniques and controlled burns.
You are welcome, Marcus. I look forward to your draft and to discussing how to integrate adaptive management into your design.
Listen again to part of the conversation, then answer the question.
In the Sierra Nevada, mechanical thinning, followed by low-intensity prescribed burns, significantly reduced crown fire risk compared with either treatment alone.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.